In this problem, or in this video rather, I'll be going over problem number 13, which is a worthwhile problem for us to go over because it's one that seems to go against our general basic rule, deciding whether or not to use IP or CP. Of course, our basic rule is the following. If there's a horseshoe as a part of the conclusion we're asked to derive, probably going to be an ideal candidate for conditional proof. If there's no such horseshoe in the conclusion, probably going to be IP. So looking at 13, we're after the E. Obviously there's no horseshoe present here, so you might very well think the thing to do here is to do indirect proof. So let's see how quickly that would work, what that would get. If I assume the opposite of what I'm after E, so the opposite of that is not E, assumption indirect proof. What can I now do with that not E? And it seems to open a useful door here. I can do immediately 2 and 3 modus tollens. And by doing that, I'll get the negation of that entire antecedent, everything there in brackets. So I get not C horseshoe D horseshoe C. And this is something that's rather nasty to deal with here. What can I now do to line number 3? Well, I could do a series of material implications. I could switch each of these horseshoes to wedges, which it seems would in turn set up then a De Morgan's, distributing this tilde on the very outside. And you could continue to break that down, and eventually you would be able to get a contradiction out of it, something of the form A and not A, but certainly that's not a fun, easy process to go through. So let's go against our assumption here, let's go against our basic rule, and see how conditional proof might work. So again, keep in mind, our rule for determining conditional proof or indirect proof is just a general rule. It'll usually work for us, but it's not always the best option. It doesn't always lead us to the easiest option. So certainly in this problem we could do indirect proof, but it turns out to be fairly long and nasty and difficult. So let's think about an alternative possibility here. What would this proof look like? What would this problem look like if we chose instead to do conditional proof? Obviously we can't use the conclusion as our guide here. So we're going to have to use the only premise given to us as a guide and determining what to assume. We're after the E, and E only appears once in the problem. It is in fact the consequent, obviously, of a horseshoe statement. So think to ourselves here, how could we possibly get the E by itself? It's the consequent of a horseshoe statement. What rule allows us to do that? Modus ponens are very first rule. But of course, to pull off modus ponens, we need to have, in order to pull off an MP, we need to have the antecedent. So the antecedent here is going to serve as our guide as to what to assume. And once we realize that, we can stick with our general rule in conducting conditional proof. Indent and assume the antecedent of what you'd like to have. I'd like to have this antecedent here so I can get the E by way of modus ponens. So I'll assume the antecedent of the antecedent, so to speak. The antecedent of the left-hand side of the statement is just simply C. So that'll be my assumption. ACP, assumption conditional proof. Now that I've assumed the antecedent here, just ignoring for now the consequent, just examining the antecedent, now that I've assumed this part, what I'm after is D horseshoe C. So the question becomes, how can I turn this single variable, the C, into D horseshoe C? And you might think to yourself, multiple horseshoes in this antecedent, so multiple assumptions. And that's a good thought, that generally does work, but you'll notice here in examining the left-hand side of the first premise, the parts here have a common variable. There are 2 C's in it. So when we see something like this, we know we need not take on an additional assumption. We can turn the C by itself into D horseshoe C. This no doubt is becoming quite confusing, but here's how it works. This again is why it's worthwhile to create a video for problem number 13. It is fair enough kind of confusing stuff. I can turn C into D horseshoe C, first of all by way of addition. I need to introduce the variable that's not present, the variable that I don't have, namely the D. So what's going to allow me to do that? Well, again, addition. But let's think one step ahead. When I do addition to line number 2, I'm going to obviously end up with a wedge statement, and what I want is a horseshoe statement. So what rule is going to allow me to switch that wedge into a horseshoe? Well, of course, material implication is going to do that. But when I go from wedge to a horseshoe, there's got to be a tilde to take away, and presently I don't have any such tilde. So that leads me to believe not only do I need to add on a d, the variable I don't have, but I need to add on not d, so I can set up material implication. So here again is what it looks like. To addition, I'm going to add on the variable that I don't yet have, the d, rather than taking on a second assumption as you might think. I'll just introduce it via addition. Not only the d, but not d, tilde d, so I can set up a material implication. So I'm not yet ready to do that impl. The tilde that I'm going to take away needs to be out front, and here it's negating the second disjunct. Easy enough to take care of that. 3, reverse the order of the disjuncts instead of C or not D or C. And now, to line number 4, I can do that material implication. I can do impl. Wedge to horseshoe, take away tilde from the first variable, and I get D horseshoe C, which is precisely, you recall, what I'm after. So I'm now ready to discharge my conditional proof, joining the first line and the last line together via horseshoe. And that'll be my line number 6. C horseshoe parentheses D horseshoe C, justification 2 through 5 CP. And now I'm not done yet. I need to finish it off, easy enough. 1 and 6 mode exponents for line number 7, and I'll have my E. Now you could have solved problem 13 by abiding by our basic rule. You could have done it with indirect proof, but as you can tell here, line number 3, that's fairly nasty to work with. You could get there eventually, but by examining the problem in some detail, by thinking my way through it in advance, I see that using conditional proof is a lot shorter. Not necessarily easier, that's a fairly tricky step, but one that will no doubt come up again. So it's much shorter, not necessarily easier, but once you realize what to do, it is a fairly quick problem, not too much of a difficulty here.